This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this video is on implicit differentiation. Given an equation of x and y, two variables, we think of y as a function of x, and we want to find the rate of change dy dx. So we'll do an example here. So consider the equation for the unit circle, which is x squared plus y squared equals 1. So if we want to find dy dx, we'll use the technique of implicit differentiation. First, we're going to differentiate both sides with respect to x. So we have the derivative with respect to x of x squared plus y squared, the left side, equals the derivative with respect to x of 1. Now we'll simplify and we'll have to apply the chain rule. So the derivative with respect to x of x squared is just going to be 2x. And then plus, since we're thinking of y as a function of x, we're actually going to have to use the chain rule here. So we'll pull that power down 2, so 2 times y times the derivative of y, or dy dx, equals the derivative of a constant is just 0. And then all we have to do is solve for dy dx. So we'll subtract 2x to the other side. We have 2y. Dy dx equals negative 2x, and then divide by 2y to get dy dx equals negative x over y. So let's check our work by plugging in a specific point and seeing if it makes sense. So we found dy dx to equal negative x over y. So we're going to check our work by considering the derivative at the point negative square root over 2, negative square root over 2. So that's the point right down here in the third quadrant, halfway through that quadrant. So we would expect the slope of this tangent line, if we drew it in, to be negative 1. That's what we're hoping our outcome will be. So let's try it with the derivative we got. So we got dy dx equals negative x over y. So we'll plug in our coordinates that we have. That's negative x is negative square root 2 over 2 over y is negative square root 2 over 2. So we can see, since the numerator and denominator are the same, that's just going to be 1, and we get negative 1, which is the slope of that tangent line, just like we expected.